Salam alaikum, guys. Welcome for our Cambridge. So this is the Cambridge International AS and A-level Mathematics syllabus code 9709 for pure mathematics 1, 2, and 3. Candidates have been asking and messaging in my inbox about this particular paper for March 2026 exams. Though it is still early, so the paper is not yet circulated, but here it is. And to clarify, which country is supposed to take this March edition? So this specific exam series is designed to align with the Indian academic calendar. So the main beneficiary of this particular exam is the candidates from India, particularly Zone 5. So this is for alignment with Indian board exams. So the March series allows Cambridge students in India to result at the same time as students taking the national board exams. Like in India, they have the CBSE, they have the ICSE, and they have the state board. Again, it also aligns with the college admissions, so it enables students to apply to undergraduate programs at the Indian universities immediately upon completion. But other countries might not have access into this particular exam. Again, it is the same series, like we have 9709. This is the pure mathematics syllabus, option 12, that is given across the world, that the Indian also will do. So for those preparing for May June series, which is starting this late April, actually the first paper comes on 28th of April, that is next week Tuesday. You're supposed to start with your practical skills, physics advanced practical skills, and then on Wednesday 29th you will be sitting in for this paper 1, that is pure mathematics. So let us look at this paper that the Indian candidate did, and maybe possibly guess on what to expect. It could be exact, it could be pointing somewhere, but let's see what has happened in this March 2026 series. Okay, so let's look at the question number 1. It contains a total of 11 questions, so we are going to handle maybe around 5 questions in this video, and part 2 we will do maybe 6, or we can do 6 and do the rest of the questions in part 2 of this video. Of course, the list of MF19 that contains the formulas is also provided for your own good, at least to help your calculations. You need to show all working, read the instruction as required before you start. So let's look at what we have here. So this is question number 1. The equation of a curve is y equal to x cubed minus 3x squared plus 9. So this is the equation of the curve. So you are told find the coordinate of the stationary point of the curve and determine their nature. So their nature in this case could be either the maximum or the minimum. So for you to do this, you find the derivative of this function, so you simply differentiate. So what we have in the first question is y equal to x cubic minus 3x squared plus 9. So we need to differentiate this, so we find dy dx, or you find the y prime. That is simply the same. If you differentiate x cubic, you will have 3x squared, and then we have minus 6x. When you differentiate this from basic differentiation, bring the power down and multiply by what we have. So 2 times 3 gives us 6x, and then we subtract the power by 1. So when you subtract the power, 2 minus 1 becomes 1. So you simply have 6x. The same is applicable here. We have bring the power down, it becomes 3x. Subtract the power by 1, so it is 3x squared. So this actually means that we can equate this to be 0. So y prime, if I try to rearrange this, I will have it as 3x squared minus 6x. So this is equal to 0. So we want to determine whether it is minimum or maximum. So we can solve this. I can factor out 3x. So I have 3x then into x minus 2. So this is equal to 0. So what this means is that either x is equal to 0 or x is equal to 2 when you solve. So x value is equal to 0, or we can say that x value is equal to 2. So now we can determine whether it is minimum or maximum. Let me take this up a bit. So determining whether it is minimum or maximum, I will substitute the value of x. So when x is equal to 0, what happened in this case is that y is actually equal to 9, and this is what you have seen here, 9. And you can put when x is equal to 2 by substituting 2 in these x values. You simply have 2 cubic minus 3x squared, which is 3 times 2 squared plus 9, which will give us 5. So when x is equal to 2, this implies that y is equal to 5. So we are going to go ahead again to differentiate the second time in order to determine if it is maximum or if it is minimum, by having the second derivative y double prime is going to be 6x then minus 6, because this is the first derivative, and when we differentiate, bring the power down, 2 by 3 gives us 6x, then we will have 6, then that is the second derivative. So when what this means is that when x is equal to 0, in this case, when x is equal to 0, then y double prime is less than 0. And if it is less than 0, this is maximum. This is maximum. When x is equal to 2, when x is equal to 2 in this case, we are going to have the second derivative y double prime to be actually, this is less than 0, so this is greater than 0. So this is greater than 0. So if it is greater than 0, it is minimum. And this is how you should have been able to get your, how many marks is this? 5 marks. So you have the first mark here, the first one here, then you have the second one here, the third one by finding the values here, that is 3. Then you have this by differentiating this the second time, you have 1 mark, and finally 1 mark here determining the maximum and the minimum. So it is 1, 2, 3, 4, 5. So this is 5 marks. Okay, so let's proceed to the second question. Question number 2. So you have the diagram here. The diagram that you have, the diagram shows a triangle ABC with AB 12 centimeter, AC 9 centimeter, CAB is 0.8 radians. So in this diagram, we are supposed to find the perimeter of the shaded region, this particular area that is shaded region. So we are going to apply Pythagoras theorem. We look at this side BC, and then we simply have you know, by Pythagoras theorem, if you draw this side, we looked at the adjacent, the opposite. If we look at the adjacent, we look at the opposite, and maybe we consider the hypotenuse, the longest part. So in this case, we are going to consider this BC. So if I take BC squared, and this is simply 9 squared. We have 9 squared here, so this is 9, so it is squared, plus 12 squared, minus what we have in this side, because there is an included angle, so this is 2, this is 2, we multiply this by 9, by 12, 9, 12, then we multiply by cosine, the horizontal angle, so it is cosine of theta, which is cosine of 0.8. So this is what you are supposed to do. This will give you BC to be, plug this in your calculator, you get 8.63 centimeter. 8.63 centimeter. Then you find the arc length. So the arc length is given by r theta, and this tensile length in P1, and it is also in MF19. So in this case, r theta, we have simply 9, multiply this by theta, which is 0.8, and then you find the perimeter. So the perimeter therefore is going to be this BC that we got, which is 8.63 plus 9, multiply this by 0.8. You should be able to get 18.8. And this 3 added is the distance from, because the shaded region, so the distance from here, this point, this is 3, so this is why we added 3 here, so you get 18.8 centimeter. And how many marks are those? That is simply 4 marks, and you should have been able to prove that. 1 mark here, then you have another 1 mark here, that is 2, 1, 2, then have 1 mark, and finally another 1 mark here, that is 4. Okay, so let's proceed to the next question. Question B, you have to find the area of the shaded region. Give your answer to correct to 3 significant figures. So we are going to look at the triangular area. So the triangular area, to take the black pen. So look at the triangular sector. This implies that we are going to have a half times 9 times 12. In that case, the vertical and the horizontal, so that was a cosine. So this is going to be sine of that angle, so sine 0.8. This implies we are going to subtract with the other side, negative a half, then 9 squared, multiply this by 0.8, which is the included angle. Plug this in your calculator and you get 6.34 centimeter squared. So this is the required solution, and this is 3 marks. So by all these calculations, you could have gotten your 3 marks. Arranging this, and you get your marks from here, there, and there. So this is 3 marks. Let's proceed and see the next question. I want this video to be 15 minutes, so we will continue with the rest of the question once the time elapses. So let's look at the next question. Here we have question number 3. So this is question number 3. The graph of y equal ax squared plus bx plus c has its vertex. The vertex is those endpoints at 3, -5, and it intersects the y-axis at this particular position, 0, 31. So you are supposed to find the constant a and b. So again, you know that when x is equal to 0, y is equal to 31, and the center will be 31. So we are going to find the derivative. We will have it in terms of that calculation. So let's go ahead and do that. You can pause the video if you are preparing for May June exam and try your luck. By now you should be able to handle a paper like this.